Good afternoon, everyone. Very warm welcome for the today's webinar, which is Achieve Design Realism with Stratasys J Series 3D printers. So this webinar will be presented by Mr. Ganesh Babu, who is our General Manager in Applications. Uh, to tell you more brief about Mr. Ganesh Babu. So he hails from Bangalore and is a graduate engineer. So he has been professionally serving Indian industries at various capacities over the last 3 decades, working at various capacities from design to manufacturing and to productionize parts and products. He has held various senior positions of management associated with subtractive and additive manufacturing technologies. With additive manufacturing, he has had the privilege of being the first Indian to extensively work on the SGC resin-based additive manufacturing technology from Israel and has been handling business development of Stratasys AM technologies from the year 2000 onwards. So this is about the Ganesh sir. Uh, to tell about brief about this GoToWebinar tool. Uh, there will be an question and answers or discussion at the end of the webinar. You can type your questions in the chat window. You can type your questions in the chat window, or else you can raise your hand. There is an option to raise your hand. We can take all your queries one by one, and Ganesh sir will be able to answer the your queries. Also, as of now, everybody will be on mute. I will be also sharing the video recording and the PPT on your email ID on Monday. Uh, Also, there are few couple of videos in this presentation, so I request everyone to kindly use your headsets for better sound quality of for the videos. So, Ganesh sir, please take it ahead.
Well, thank you very much, Pranjal. First of all, I welcome all joinees who have taken time to join us for today's webinar. As the subject that we are going to focus today is going to be on design realism. How do we achieve design realism with Stratasys J series 3D printers? So, well, before stepping into understanding on these Stratasys J series printers, I would first of all like to take you all through with a brief overview in terms about design tech systems. With design tech, we have multiple business verticals to talk about. We have been VARs for CAD/CAM, CAE, and PLM solutions. Apart from that, we have a very, very strong engineering services domain area, which is providing product design and development services, starting from concept to even setting up production lines. Our engineering service team has a very, very strong expertise that could handle various industrial challenges to set up and work on complex designs in product design and manufacturing. Well, for AR and mixed reality experience, we have an exclusive team that could also handle your requirements when it comes to augmented reality and mixed reality experiences. So we are an organization who are 25 plus years in the industry. More importantly, like our presence in India, all across India, as well as in some overseas countries as well. We have a strong customer base as well as a highly professional and experienced team to support your needs. Well, for today's agenda, let me begin to talk about and take you through with additive manufacturing, a very short brief in terms about what AM is all about, and we'll step into understanding more on Stratasys as an organization. Stratasys as the OEM are the manufacturers of various additive manufacturing technologies today, and let us see that more in brief as well as in detail when it comes to the PolyJet technology. So J series, what does J series stand for? I will explain on the PolyJet exclusive J series printers. Additive manufacturing solutions of J series comes under various systems. So each are very unique to various applications when it comes to industry verticals as well. And design realism, while we talk about high fidelity models, the design realism, what makes it so very important to achieve these high fidelity models by a single push of a button is what the focus is going to be. And the workflow, how to create an input file in order to achieve these high fidelity models. So all this will be covered, and then we will have some time for taking your questions and also discuss on your area of interest for additive. So well, Stratasys, the 3D printing solutions company, today is proudly boasts about 35 years in the industry now, more than 3+ decades in the industry. They have been leading additive manufacturing from inception. So well, today Stratasys offers 5 technologies, and we'll see each of them. More importantly, like along with the technologies, it is the material partners who work along with Stratasys for having high performance polymers that are used on these technologies, as well as the software plays a very important role. So the hardware, software, and the materials, all of them contribute to what today's Stratasys is all about. Being world leaders in additive manufacturing, all these complements to various industry verticals across manufacturing as well as healthcare. The focus here is not just the Fortune 500 companies are, but even software giants like Google and various other organizations. I have the privilege of working along with Stratasys additive manufacturing solutions. So while we talk about 3 decades of innovations, there is a never-ending story with Stratasys from the days of inventing the FDM technology as a patented fused deposition modeling technology. They have been reinventing the wheel for additive manufacturing. So innovating, always inventing newer materials, newer systems, and that's exactly what makes today's Stratasys as leaders in the additive front. So most widely used 3D printer across the globe are Stratasys product lines. So where does all this happen? Well, there are dual headquarters of Stratasys at Eden Prairie in the US, Minnesota, and Rehovot of Israel. So there are multiple manufacturing locations, countries of operations, as well as whole set of resellers. And we are glad to be Stratasys' oldest partner in India. We are Stratasys Platinum partners. So let me take you through more on the technology front from Stratasys when it comes to additive manufacturing. Well, on the far right of your screen, you will see industrial FDM. So the inventors of the FDM technology are Stratasys, the patented fused deposition modeling, where thermoplastic filaments are extruded layer upon layer. And well, today standard engineering grades as well as high performance grades of thermoplastics are used in the FDM Stratasys additive manufacturing systems. So on the far left is today's focus, PolyJet. PolyJet, as the name suggests, poly meaning multi-materials for a single print if you desire to have the high fidelity model. That's what it calls for. You mix multiple materials in order to achieve high-end, high fidelity models. I'll dwell more on PolyJet because the subject today is going to be covered primarily by PolyJet technology, but let me also take you through the stereolithographic SLA process from Stratasys. The Origin P3 that you see is for batch manufacturing or for production parts that could be manufactured from a 3D printer. This is digital light processing technology from Stratasys. Well, then we also have SAF, it's powder bed fusion for high volume production. Here we are going to look at highly intricate, accurate parts when it comes to working with polyamide as well as styrene based materials, etc. Now let's take a look at the industries that have been adapting to use additive manufacturing. So aerospace, automotive are the majors, but when it comes to medical applications, when it comes to transportation or dental applications, then we have the old consumer goods, consumer product manufacturers, design firms. All of them today are using additive manufacturing for their design realizations in physical form, and moving beyond the design realms are the production and manufacturing tools that have been made with these Stratasys technologies. So it's no more just prototyping, it is beyond prototyping with Stratasys additive manufacturing systems. So let's also take a look at why Stratasys 3D printing. Today, Stratasys 3D printing means Stratasys as a company understands the customer needs. Based on what the customer challenges are, ideally, Stratasys focuses on those primary areas in developing material on a larger front. Since additive manufacturing has limited material choices, the bandwidth of what the customer needs enables Stratasys to come out with technology solutions in additive and the materials that go along with them to meet almost every need for industrial applications, and primarily customers, whether it is going to be the education sector or the aerospace high-end sectors of automotive and aerospace. All the materials and the systems could cover the entire need of customers. That's what makes Stratasys to be the chosen one for additive solutions. So, well, in India, Stratasys are 22 plus years. We have 850 plus customers, and more importantly, we have customers with more than one solution, ideally meaning more than one machine or more than one technology with them. A brief snapshot in terms of education, automotive, healthcare, consumer products, as well as aerospace and defense. Some of these names are very prominent in the Indian industry. So let me again reiterate that 5 leading additive technology platforms from Stratasys. The choice depends upon the industrial needs. The next level of utilizing additive manufacturing systems is primarily looked upon based on what the customer needs are. So now let me actually take you through with PolyJet directly as a technology, because PolyJet is where the focus is going to be in general. While we look at PolyJet as a technology, it's a patented technology. Now what you see as an image, it's a medical model that comprises parts that have been printed with multiple materials, or multiple materials that have been digitized, that have been combined together in order to achieve various gradients of finish and color, etc. So which means that what are these materials? The materials are in liquid form. These are resins. Now these resins give you outputs that are opaque, transparent, flexible, right? As well as vivid materials. What are these vivid materials? How do they combine together in order to achieve high fidelity models? And what are also these special photopolymers that are today utilized by medical and dental industries, hospitals, as well as medical device manufacturing happens with special photopolymer resins. Now, the most important customer need today is you want to have a simple workflow, whether it is creating your input file or even working on the system. While we talk about PolyJet as a technology, there is no messy workaround. You don't touch the resins. These are sealed cartridges of resin materials. And all of these is what I'm going to talk to you in terms about how PolyJet is a promising technology from prototyping or from ideas to your products. Let's take a look more in detail. The PolyJet technology, it works on the principle of a print head that keeps moving along the X and Y axis. The build platform lowers down with a pre-chosen layer thickness. That's exactly where the layer thickness choice is, whether you can work as low as a 14 micron layer thickness or on an average of 30 microns that we regularly use PolyJet technology to print parts. And with exposure to ultraviolet light, UV light, which is also assembled within the edge zone. So when the edge keeps passing after laying materials, the UV light falls over these resins and converts the liquid resins into a solid state. Hence, these are photosensitive resins that are called as photopolymer resins. Well, this is exactly how the technology works. So jetting liquid photopolymer, these droplets are cured by UV light. As mentioned, the X and Y axis where the printing block that constitutes not just the dispensing head of the resins, but also there is a roller, the wiper, and the UV assemblies that are combined together and assembled within the build head. So there is also a choice of support material. For overhang features, either you require soluble support or removable supports through water jet. It's a very simple process, ideally. I hope you people have you get the audio on this particular video that I'm going to play for you.
It's a 3D printing method that makes beautiful, precise models in a huge variety of materials and colors. It works like an inkjet printer, but instead of jetting drops of ink, PolyJet 3D printers jet tiny droplets of liquid plastic. The UV light instantly cures the plastic, solidifying it. So, layer by layer, complex models.
I'm in a meeting.
PolyJet systems can build multi-material parts, soft, rigid, clear, and colorful. You can even adjust material properties like heat resistance and durability. The same technology that makes gorgeous prototypes also makes precise manufacturing tools. Designers can predict future needs and serve them now. Deliver better products faster and with less waste. Researchers have new methods of saving lives. PolyJet is reshaping industries like film, fashion, and medicine. It's helping people with great ideas improve the future. What's next?
So here we talk about PolyJet for turning design ideas or design inspirations into reality. Well, here's a smart speaker that you see with a fabric design. Now this is a plastic 3D printed part with a fabric finish. Ideally, what you get to see on the speaker is also very crisp letterings that have been embedded. All these are captured in a single print. So colors, finish are all constituted by the materials, these resins, in the PolyJet process. So let's look at what we talk in terms about concept to detailed design or the final design. This is what the end-to-end capability from concept to final design is all about. The J series printers would enable you to have your concept models in a single material or the final design by combining multiple materials, all in a single print on a single tray. So here we would like to introduce the J series printers, ideally design realism that meets your needs. So the total cost of ownership that we talk about with the J series full color 3D printers have been taken through with the J750, J850, J826. So J826 and the 850 primarily are the overall size of the build platform that we look at. The J850 comes with roughly around 500 millimeters on the X, 400 on the Y, and 200 on the Z. And also we have the J55 platform to talk about. So well, before we dwell into these systems and the capabilities that these systems offered in terms about realizing high fidelity models, let us also look at what does the workflow call for. Now, what is the input data that customers would require in order to achieve those high fidelity models is what we would like to take you through with. So primarily when we talk about the digital workflow calls for creating your CAD models in any CAD platform. Well, there are multiple CAD platforms today that could enable you to design or bring your ideas in a digital form of data, which is a CAD model, 3D CAD model. We call them in KeyShot a rendering software where you will be able to apply different types of textures, colors, text, your company logos, you can name it. And that's exactly what the rendering means. Finally, we have the interface software that we call as GrabCAD Print. Now with GrabCAD Print, ideally what you render can be called in and directly submitted to the printer for printing based on the part orientation that could be chosen by the user. Well, this is exactly what the workflow means. So earlier in the design process, the designers start working on creating CMF files. CMF stands for color material finish. And whether you want bump or any texture on those 3D CAD models with a rendering tool, you'll be able to achieve and then submit it for printing. So all this, why we do all this is end of the day, what matters for stakeholder approval or for end customer approval. We have to have the golden model in hand. How do we achieve that in a single step process? That is what is today's Stratasys J series solution talks about. So what you see as a model here is a one-shot single step process to complete the entire printing, including your texts and colors and all the details of finish. So let's talk about bringing designs to life. So what we sketch, again, through rendering softwares on each of the parts as an assembly. In an assembly, you can start working on, including your PCBs, your designs of your PCBs, your clear screens, the various exterior components that calls for a fabric design in this particular case, and all of them arranged on a single print platform. So whether you like to have individual opaque, individual transparent, or the high fidelity models, all that is possible in a single go on a single platform print. So you don't need to make a transparent part in one print and an opaque part in another one. You can combine all these together and have the entire set of parts made in a single go. So thereby what you achieve, concept models or a detailed design model and the final color material finish design. So all these possibilities can only happen with the PolyJet Stratasys 3D printers. So sketch, render, and print. This is exactly why we talk about the workflow. This should be the first step to understand in terms of utilizing what goes in as a data. How do we create it? So you model, you add style and color to the model. You can edit or you can configure them with our interface software as well. And then you submit it for printing, as simple as such. But what happens when you're looking at the traditional process without Stratasys solutions today? Traditionally, it is a complex process that involves multiple steps in order to achieve the final stakeholder model. But more importantly, ideally between 1 and 2 or 1 and a few samples, since it is made by traditional processes, you will not have the standardization. You will not have them all equally made, whether it is aesthetics or whether it is going to be the finish and so on. That's exactly where the challenge is. So with so much of problems around typically you design and then you spend hours and weeks, outsource to multiple people, spend huge amounts of money to achieve one prototype model. But those are being addressed here as a single step process with our solution, just click print. So what you design, whether it's SolidWorks or NX Solutions or CATIA for that matter, or Fusion 360, CAD modelers and so on and so forth, you would be able to render with KeyShot and then calling the KeyShot CMF files. The CMF files are called as .3MF. When we talk about .3MF, MF is a manufacturing file. So all three-dimensionally, they have been created with the CMF input that you have an extension of .3MF, which can be read by GrabCAD Print, and you can process your parts. So a simplified process and a workflow that saves time and money, and more importantly, what you get to achieve is not one colors. You'll have multiple design options that you want to achieve before you freeze what could be the final color or the final model. So you have wide varieties of color options with the design intent that you can do. So KeyShot enables to generate .3MF file for printing. So why 3MF? Because 3MF contains a full color material finish data, including the images. That's exactly why we talk about 3MF files. So there is a voxel level control ideally with these models. So you'll have a voxel, which is a three-dimensional grain structure that we talk in terms about X, Y, and Z, adding value in terms about printing high fidelity models that contain all the details. So brief touch base on what the GrabCAD Print is all about. It enables smooth workflow, as well as it's very easy and adaptive software that can be used by every user. Very quickly, you will be able to learn the software, and you'll be able to achieve much more than what we talk about the hardware or the printer is all about. And these can also be enterprise connected. That's what we talk about, print from anywhere. You can have the control of the printer even remotely. So end-to-end appearances that we talk about is finally here, whether thick, thin, solid color, Pantone colors, a whole lot, a stained glass, or you have to think about traditional ways to spray paint, for which you need to mask, and then you do the step-by-step process in order to achieve, but all of that in a single step. Traditional end-to-end appearances calls for pad printing. You need to glue the label. You need to have a shrink sleeve, and then you have to contain a liquid. But all these are addressed in one-shot printing. That is what PolyJet is all about, and exclusively the J series printer. So Stratasys, while we talk about appearance and workflow, what matters here is more importantly that the materials. So we have Vero Ultra Clear, Vero Ultra White and Black. We also have the Pantone validations with the vivid materials that we talk about. So vivid, we have magenta, we have cyan, we have yellow, all these vivid materials combining with white and clear can give you outputs. Now the auto interior snapshot here talks about what you get to see as images, including the gear shifter. What you see, you can feel them. You'll have a leather texture finish. You'll have a wood texture finish. All these are captured in a single print. So you can experience all the full colors, the vividity in your part designs. What the designer's intent is all about can be achieved. And more importantly, all these can give you enablement to fine tune your designs for freezing them for manufacturing at a next level by using Stratasys J series printer. So quick prototypes that we talk about. Today's solution again involving quite a lot of spray painting, emery sanding. Post-processing is a labor-oriented process which also calls for very high level of skill sets. Now with our new solution, you'll have the sharp text that can be precisely as the final production part looks like. You'll be able to achieve all of them with the gradients of color, and more importantly, transparencies, opaque, rubber-like, all these combinations in the new solution. So what you need in today's solution, you'll be able to achieve it. That is what the new solution of J series is all about. Now, on the right of the image that you see quite a lot of small different colored palettes here. Now, all these pebbles that we call them as are primarily more important for freezing product designs when it comes to colors. What could be the color shade? What should be the final shade of colors? That's exactly where we are looking at. So all of them that are printed here, instead of the extensive manual laborious process of mixing colors to achieve them, or to outsource them to a third party, which takes time and cost, here we are addressing all your needs in a single step. That is why we talk about the J series as a unique tool for designers. There you see a keyshot rendering outcome which has been 3D printed on the J series printer, J55. Now, when we talk about just click print, from your design desk, from your computer, that the digital .3mf file which contains CMF data is straight away taken to the printer. In a couple of hours, you have the complete realization of colors, and the high fidelity models that you want are quickly rolled out, which delivers cost as well as time saving. So full color material and finish with compact systems, very quiet, and that can fit into your office. That's exactly where the printer is placed between desks around, and these are systems that are very, very quiet. They would not create any much of noise. They don't call for a factory setup to be laid up. They can be put up in an office environment and you can start working at your desk. Here's the animation of how the J55 in terms about having a rotary table that allows a simple step in the process of realizing complex high fidelity models. So what do we achieve with all that? When we talk about vivid magenta, vivid yellow, vivid cyan, these are the three basic colors that we talk about, along with the black, the white, the clear, and the rubber-like. All that what you achieve with the J series printers are more than 640,000 colors that we talk about, 640K color spaces that you can choose. And more importantly, we also have Pantone, 1,900 different shades of Pantone. Pantone has validated Stratasys J series printer for achieving Pantone colors in a single go. So with the prime that you get to see with the J55 prime, what you see is the Vero Ultra, the exterior of the part. And at the interior of this model, the spherical model, you see the beauty of how the ocean is, the depths of the ocean that have been captured, and it's been printed in a small, clear, spherical design. So whether you have high clarity that you require from the Vero Ultra Clear or the fine details, all that is made possible with the PMMA or the glass transparency outcomes. That's exactly where PolyJet stands to give you high fidelity outcomes. So Pantone validation, as I mentioned, like meeting designers' intent in terms about qualifying a Pantone shade by making small swatches very quickly and addressing the need of achieving the exact Pantone shade on a 3D printed part. And when it comes to transparent, clear parts, there's a whole lot: automotive lighting, headlights, tail lights, all that today are being printed with the J series printer. So for translucent plastic, you will be able to simulate all the colors and the finish and the design. And these are unmatched. And let me also speak to you on what Elastico is all about. As the name suggests, it's a rubber simulation material that goes on the PolyJet J series. Well, that too exclusive to the J55, we have the Elastico material that combines to give various levels of Shore values, starting from Shore 35, going up all the way to Shore 95, and combining colors on the rubber parts. Very unique, very, very unique, unmatched. So in order to make 3D printing simple, again, I would like to remind you all, just point, click, and start printing, as simple as such. So 640,000 colors that I talked about, these are highly distinguishable and more importantly, radiance. You could see the radiance of colors, different Pantone validations, texture realisms. All these are made possible, but the hardware that we talk about, the J series PolyJet printers, along with materials and the software. So let's see how the PolyJet works. A little bit more in terms about how the PolyJet J series J55 prime technology works. So there is a static printed. Well, this is a rotary table which keeps revolving around. That static printed moves in only one direction to cover the entire area of the, or the cross section of the build tray, and we call it as a swath movement. Here's a small demo of how the system in principle works. So that's exactly where we talk about with the J55. Imagine what you could do. And that's exactly where these two gentlemen across the table have been discussing in terms about achieving high fidelity models, whether it is simulated fabric or while we talk about graphics, 2D graphics that have been actually placed on containers, placed on packagings, whether it is bottles. Now, all these simulation, including the liquid, will be achieved in a single print. When it comes to automotive, you have glass thickness simulations, rubber simulation, hood simulation, all these are possibilities. So where does all these apply? When we talk about applications for engineering, when it comes to J series, whether it's fit form or functional evaluation, FEA analysis can also be made with the gradients of color that you can achieve. You'll have labeling that could be done, sectioning, and you want to have different versions of a design that needs to be printed and evaluated before it can be freezed for the final design. All those are possibilities. So fluid channels, lighting components, and transparent parts. So more importantly here, let us also look at what does a model shop take. It takes huge amount of time, right? So what does the product details of J55 constitute in terms about a single layer thickness, that is, we call it as high quality layer, and that layer is of 18.75 microns, right? And you'll have a printing area up to 1174 square centimeter area that could be addressed on the rotary bed. More importantly, when we talk about high precision and achieving very tight dimension tolerance, 100 to 150 micron dimension tolerances that are achieved. Well, 5 digital materials that go in with the J55, but whereas with the J8 series, we have 7 model materials and the 8th is the support material. So there are exclusive materials like biocompatible for medical applications. And well, let's look at what customer solutions today from the J55 are achieved. Now here we see a streamlined software workflow that I explained to you all from CAD, what you do with KeyShot, and finally, what do we achieve. Now, here is a company called as Kinetic Vision, whose director of innovation takes us through with what it takes for achieving a high fidelity model for the consumer goods manufacturing. So what he's holding is a single material print on his left, and the high fidelity model has a single step process that he has achieved with the J55. Here's a case study that talks about achieving high fidelity models on the J55.
Kinetic Vision is an R&D consulting firm that's focused on developing and integrating advanced technology to drive innovation. There are sales and marketing going on every day on shelf at retail through packaging. And that packaging has to impact that specific consumer personally. When you're developing a product around packaging, it's critical that the end decision maker can hold the final product in their hands. And that's where 5 comes in, is that we can adapt to consumers faster and at a higher level than we've ever been able to do before. By being able to have 3D printers available to our Kinetic Vision design team, we're able to shorten that design cycle. It's incredible, the impact of the J55 on our process. What we typically do is, really amazing images or graphics, and we put that up on the wall, and then we let the consumers or the clients view it. However, with the J55, we can actually get there in just a few days to a place that is on the edge of reality, which is something we've never been able to do. We actually coined the term retail ready prints to where it looks like it should be on shelf, and where in almost the same amount of time we were only going to here. I mean, which one would you want to show, right? So for this particular concept, we were doing a design sprint. We wanted to see what would actually happen if we added the J55 to that process. And so we decided to do a retail drink. And so we developed a brand, we developed graphics, we developed structure, and we did all of that within a 2-week period. Not only are the graphics intricate, colorful, but we're playing with opaque materials, we're playing with transparent materials, which is one of the reasons why we are leveraging the J55 printer, because we can take advantage of all of its unique features to really make those ideas come to life. So we have alternate lids that we've created. You can see it, that actually intertwines and works. There's actually liquid printed in this, so you're actually seeing the color that's actually inside, that the passion tea would actually be colored. So it's printing completely transparent and colored transparent colors at the same time, as well as opaques. So if we're showing this to a client, we can give them every detail of the product itself, which is absolutely incredible. Being able to leverage PolyJet technology, the J55, we're able to jump past some of those firms that are not adopting that technology. We sent this to a customer, and they called us and said, hey, where can we actually buy this product? Because it looks amazing. We said, no, that product doesn't even exist. That's just a product we created. And they were stunned because of the J55 print. They thought it was actually real. We give our customers a competitive edge. They're able to take their product to market faster, develop better products, be the best on shelf. To be able to hand this to a client and to watch their eyes light up, their mouth open up, and say, oh my goodness, how did you do this? How long did this take? That's their responses. it's amazing. And so the impact for them is incredible. And obviously, all of that reflects back on us.
So there you go with the video. There is quite a lot of clarity in terms about how these high fidelity models are achieved, starting from sketch, going up all the way to have the final design and using the printer. It's as simple as such. The workflow also doesn't call for too much of complexities, except till the time you create your design and be ready to fire the print. It's a single step process. Very, very simple. And post printing, it is support removal and a minimal post processing will be called for. Either you can buff to have higher levels of transparency, and that's it. So, well, not just the industrial applications that we are looking at, but more importantly, here I am presenting to you the digital anatomy printer from the J series as well. A couple of slides to talk about how the medical world today, their needs have been addressed, ideally because no matter what we look at, any other process of having a 3D printing solution that today that we offer is primarily printing human anatomies, whether it's going to be the heart, the brain, or any anatomy that we call for, whether it's a liver section or the lung section that needs to be printed, or for that matter, any given bone models that you need to make. All these are made possible with the DAP printer because that comes along with exclusive materials, medical materials that we talk about. So for achieving biomechanical accuracies on these models, musculoskeletal outcomes, and you can name it when it comes to any challenging anatomy where surgeons today are dependent only on CT and MRI data. But here we are enhancing surgeons with a 3D printed anatomy with biomechanical properties, which ideally means that they can prepare for surgery well before the surgery date arrives, because these models can be made very, very quickly from a CT and MRI data. So the workflow here again is CT MRI data can be converted into a DICOM file. And with that step, the DICOM file, we have the medical models in STL format, where the DAP printer that comes along with exclusive materials. We talk about bone matrix, radio matrix, gel matrix, tissue matrix. So the combination of these resins, along with Agiles, the rubber-like material, that gives you values in order to print a heart. For example, a Shore Zero. A Shore Zero means with biomechanical properties, a 3D printed parts where the medical faculty need not have to work only on cadavers or on patients to gain experience. They can have a printed model, start sectioning, suturing, start working around, prepare well before going into an operation theater. That's exactly where the various advancements for medical applications have been supported with the J series PolyJet printer. So students here in this particular case study, Dr. Shi Jun, he talks about treating patients by analyzing a 3D printed model, which gives them more clarity in terms about highly challenged cases, patient cases that could be addressed by preparing for surgery, as well as training his students to work on 3D printed models. So there is ultra soft material, which gives the feel of the hard tissue as it is. So while we talk about tactile feedback with biomechanical properties, they are as good as clinical cases to work upon. So cutting, suturing, even if there is a device to be placed inside, all these planning happens with a 3D printed anatomy. Now moving on, the J series, beyond the industrial use, the medical applications, we are now looking at innovation kit. It's called as Fabrics Innovation Kit. What is it? Fabric Innovation is On the print platform, on the print bed, you can load a fabric, and on top of a fabric, you have a 3D design that you can print. That's exactly what the J series fabrics printer is all about. So now, what do we achieve here? Today, fabrics that have been 3D printed, designers are working on to create costumes. And these costumes with 3D printing, it's quite a lot in terms about the eye fidelity that with which these fabrics are made. How are they achieved? Let's take a quick look here. There you see the J850 fabrics printer that has all the color materials that go in. Now these materials combine to give you the realization of what the design intent is. So the fabrics innovation kit that constitutes can give you a whole lot of design features on a fabrics that can be printed. Let's take a closer look. So more designs, which means all these possibilities can only happen with the J series printer, and ideally that's because of how the printer has been built up. The algorithm of the printer is as such. Today we talk about voxel level printing here again, because these prints on a fabric has to be used as a costume, and that's exactly where it scores. Few more closer looks in terms about what has been achieved on fabrics. Quite a lot of design intent realized on a fabric that goes on for costume manufacturing. So there we go. The innovation kit, like it's unlimited possibilities, endless possibilities. So there is no limit for your designs. Anything that you design, anything that you can conceive and design can be achieved with a great tool, the Polyjet J series additive manufacturing printers or 3D printers. So this exclusivity for the fashion industry means beyond the realm of industrial applications. All these happens with vivid materials, vivid colors. And remember, all these materials are individual CMYs, cyan, magenta, yellow. All these are individual cartridges. But the technology performs to realize, all of us are able to realize all the high fidelity models. When the dispensing happens on the build platform, that is where the digitization happens, the mixing of materials, which gives highly precise, unmatched levels of high fidelity outputs. So translucent plastic achieving the automotive interiors and the exteriors when it comes to tail lights, headlights, etc., are highly challenged by only traditional manufacturing methods, which takes huge amount of time and cost. So achieving texture simulation, wood simulation, fabric simulation, endless possibilities. It's your imagination, as it rightly calls. What you would like to mimic and feel in terms about what your imagination calls for, all those are possibilities with the J series printer, right? So, well, I've come to the end of my today's presentation for having to achieve high realisms in 3D printing using Stratasys J series printer. Well, you'll be able to reach us on social media as well. And more importantly, now it is time to take your questions and get into discussions.
Thank you, Ganesh sir. Thank you for your presentation. So as discussed with, as I mentioned to everyone, so I will be sharing the PPT and the recording on Monday on your registered email ID. So moving on to questions, sir. Uh, we will start the questions. So first question is from Mr. Just a minute, sir. I will just type. Yes. So we have one question from Mr. Sham Sundar. Actually, he has typed the couple of question. So Mr. Sham Sundar, if I have unmuted you, if you can ask the question. I have unmuted you because he has mentioned 3 to 4 questions. Mr. Sham Sundar. Okay, so I think yes, yes,
Yeah,
Mr. Sham Sundar.
yeah, hi Ganesh, how are you?
Oh, well, I am good. Thank you, Mr. Sham. Hope you're doing well.
Yeah, good. Yeah, I think many of those questions have been answered in the course of the presentation, I guess. I was keen to understand a couple of things in specific, especially when you talk of resins of different types and grades, etc. Have you looked at developing resins that are closer to being eco-friendly or biodegradable?
Well, a very important question when we talk about greener environment in the world around us. Um, Here, these resins are primarily thermoset resins. They are not thermoplastics, and primarily they post curing under UV from a liquid state when it gets hardened. You know, the ASTM standard has clarified very clearly that these can be disposed of as plastic waste, as simple as that. However, end of the day, what happens is these plastics, though they are not recycled as thermoplastics, these thermosets are being recycled for maybe even preparing roads and so on and so forth, along combined with certain concrete mixtures, etc. That's exactly where the disposal happens. And the support material, which is soluble in nature, that literally gets liquefied and it can be washed off in drains, as simple as such, without causing any much of damage. And that's exactly how these materials have been worked around and prepared.
Okay, but are there attempts to develop anything which can be really eco-friendly or biodegradable?
Well, yes, there has been quite a lot going on at our R&D front because Stratasys, spends huge amount of their incomes on the R&D sector to develop more and more materials, but keeping in mind about environmental conditions. That's exactly where, and even specific to applications, that's exactly where we have been able to come forward with biomechanical properties for the medical applications. And there's a whole lot happening, but when it comes to, yes, on the Stratasys front, there is materials which have been developed and also used on the powder bed fusion SAF technology. We call it as derived from castor oil. It's a 100% green material, which is recyclable and more importantly, and very similarly on the other technologies also down the line, without compromising on the functional aspects, the mechanical properties that are so very demanding for industrial applications, keeping that in mind, and again ensuring that these materials are also environmentally safe to be handled, has given way for the development of flame smoke toxicity certified materials, etc. And that is the core area that Stratasys is focusing when they develop materials. Yes.
Okay, sure, thanks. And other one was primarily on the CMF part. I know you did talk about replicating the Pantone colors. Probably, I think seeing is believing. We can connect with your local team here and understand, how close that color
Absolutely.
representation happens in the printing.
Yes.
Also, in a single setting, if say the different finishes that you can achieve, gloss versus semi-gloss versus glossy, or the amount of transparency that you can play with within the same setting. These are a few of the specific questions that I had.
All right.
As I said, it's more of looking at few references just to believe that, how it is being achieved, and does it really qualify as per the designer's intent in terms of final touch and feel of the product?
Well, I'm so very glad that you covered quite a lot in your questions that calls for industrial design department heads who are more focused in achieving true to what the design intent is all about. So what is conceived at the design desk in product development has to be achieved. And that is exactly where the J series printers give you the outcomes. And as you rightly said, probably either me or my team members could catch up with you with some of the printouts, as well as if I don't know where, if at all, if you're close by around Pune, or you can even visit our facility which has the printers. The Stratasys office is also in Pune, which has the demo systems or the experience center where a whole lot of printouts have been displayed, and you can see the printer live in action. And we can
Right.
also take up a POC and start working for you in any core areas for achieving color, finishes, etc. But yes, to answer your question, glossy, matte, all these design intents uh, on the printer to a large extent can be achieved in a single go on multiple designs that can be laid out to fill up the entire platform and achieve both glossy as well as uh, matte finish outcomes using our J series printer.
Yeah, and my last question is, I probably have not typed in there. This is a kind of a challenge that we have been trying to deal with or trying to address, but not completely happy with the options that we attempted in the past. Looking at specific features like the live hinge, which seems to be a difficult task with whatever processes that we tried in the past. That's another point that probably I would like to experiment with and check. How does your printer give us realism in terms of the performance or the functionality that would be required, which comprises features like the live hinge?
Very good question. Now, when we talk about again opaque, it can be opaque, transparent, rigid materials, and in combination with flexible material. Now, the flexible material for live hinges, in a single go, you will be able to have the rigid, transparent, or rigid opaque, and the combination of flexibility for a hinge region with shore values that can vary from shore 35 going up all the way to shore 95. And it is subjective to the design, the wall thickness of the hinge area, and the performance for which it is being prepared. Can it withstand the rigors of testing multiple cycles? Again, would be a question for various of our customers. Now, yes, in the past, Polyjet had limitations in terms about the flexible material options. Today, we have a high-end Agilis material that is predominantly high strength when it comes to hinge manufacturing in certain designs, and they score over, and they work very well for multiple cycles, combining digitally along with the rigid materials. You can also explore various hinges with different Shore values, and then try to have a feel and test that truly perform very well, and those are available now, and the newer materials can address your challenges.
Sure, Ganesh. Thank you.
Welcome, Shyam. Pleasure talking to you. Thanks for all the wonderful questions that you put up.
Thank you, Shamsundar sir. We will definitely connect with you. Our team will connect with you, and you can take it further, whatever you have asked about it. So moving to next question, sir. We have one question from Mr. Bilal that how can I get the KeyShot app? Is it a app or is it a software?
Well, it's a software. You can purchase that as a software, as a rendering tool, and various industrial design houses do have KeyShot as a rendering tool beyond the CAD platforms that they are. So it has to be purchased. It's a software.
Okay. So we have next question from Mr. John that is it possible to print the eye lens?
Yes, for the medical applications, these eye lens, thin-walled eye lens, for various testing and evaluations have been already tried out. But again, when we talk about skin contact or under the skin for medical applications, they are limited to a few hours of utilization, not beyond it. Unlike you need to actually have them used only for minimal time, and these lenses are very precisely printed for various medical evaluations as of now, and not directly for end-use customer applications.
Right. So I hope everybody has typed your question. So we'll wait for another say 20 seconds, sir. If anybody is having any question, or you can raise your hand. I will just check if anybody has raised your hand. Yeah, just a minute. Yes, Mr. Venugopal, you have raised your hand. I have unmuted you. Can you please unmute yourself and ask the question? Mr. GK Venugopal.
Yeah, yeah,
Hello, sir.
yeah. Hi. Uh,
Hello.
Good evening, Prananjal and Ganesh Pogar.
Yeah, good
Good evening.
evening.
I would
Please
like
go ahead.
to, yeah, I would like to. Can you hear me, please?
Yes, sir.
Yeah,
Yes,
I
sir.
can
We
hear
can.
you. Please go ahead.
Yeah, yeah. Ganesh Pogar, just I would like to know, like, as I spoke to you on yesterday, like on the automotive side, like with the J series print, I could able to understand with the lightings and tail lamps. That's one observation of the presentation from the GS series. I would like to know the lattice structure of this one, how we are going to come up with the printing solution for this one, apart from the rendering side, because the render will take some more importance in designing. When you put a render for the component, when you design and put a render, it asks for the mass properties, everything clearly, and when we calculate the design value for the component. So here I would like to know the lattice of that particular lighting component.
So, well, for the lighting components, for all these clear components, we are not going to talk about a mass wall thickness over there. We would like to work around with, say, predominantly for a thickness which is say around 3 mm max or 3.5 mm max in certain critical areas. If not, it further falls down to 2 mm or less than that. Now, the lattice is the inner core area that you mean from the exterior skin that we talk about, either to render or to. Here in such thin walls, it's a through and through lattice through which the color impregnates during the print process. So, but when we talk about a solid mass, whether it is a cube or a sphere for that matter, there we try to limit keeping the inner core with a white material in order to have better colors that gets rendered onto the exterior. We preferably choose, the software allows you to choose whether you want to have an inner transparent or an inner opaque, and what could be the inner core material that your choice should be. And also when it comes to transparent parts, we have the Vero Ultra Clear. Now this Ultra Clear has got higher levels of transparencies in comparison to polymethamethacrylate, PMMA for that matter, or
Okay,
polycarbonate. Now,
okay, sir. Yeah.
so here it is again, we look at what the core material, the transparent material, the selection of the software allows you to select and go upon achieving the best transparencies.
Okay. Like, because one of the tile lamps, if you go for the red, because the coefficient of scattering is a little bit different for the tile lamps compared to the headlamps. So the
Right.
variation with the properties could also, as like the thickness will be different. The variable thicknesses will comes under into the considerations. So this is what
Right.
actually I would like to come up with, because what my observation in the presentation, because like the way which I wanted to come up with composite material conditions which could apply for the 3D design capabilities to come up with a product like not only in the automotive, like in the other areas, but in the another areas, like I mean to say in the energy sector, specifically in the company, like I can take it as like a Wärtsilä. So they're specifically into the energy sectors, like the Hughes engines and all. So maybe this J series is quite different from where they cannot work with that. But in the automotive side, I would like to see one case study of you like in the lighting. But is there any other like plastic components that we can see, sir, in the with the J series?
Well, in the J series, predominantly as we use resin based, it's a resin based
Okay,
technique. We combine resin to achieve transparent, opaque, rubber like. But when it comes to
okay.
composites, now composites are predominantly from the FDM technology that we have. Now there we
Oh,
have composite materials like nylon 12 CF, we have ABS CF, carbon fiber reinforced material. Now these are
yes, sir.
chopped carbon fibers which are already in the thermoplastics that gets extruded and laid. So even the lattice strength or the isotropic properties that we talk about, functional snaps, etc., their functioning is very, very superior, and they equate for end-use applications, which ideally means that these carbon reinforced materials are so very strong that the prints can stand on products and perform for their life. Subjecting them
Okay,
for
sir.
high-end testings, yes, they work very well.
Okay. Sir, I would like to know one more thing is like the prototyping is a main thing in this one 3D printing. So how we can come across with this prototyping like for one component, I would like to say a simple component. What could be the cost analysis for the customers that we can expect the customer can research with the 3D printing area?
Well, with
Can
the
I get
technology
something
that,
on?
yeah. Well, with the technology that you have seen today, the J series polyjet printer, it's ideally the major cost is the consumable, that is the material,
Okay.
right? Now, so the material specific to a geometry calls for what will be the total volume of material that will be called for. So that can be calculated because we easily arrive at there are various materials which start at 16 to 18 rupees per gram, going up all the way to even 20 plus 22, 25. It depends upon what type of material we choose and what is the next level of application that the product should stand up for. So based on which, that's exactly how we arrive. And more importantly, like the software that you work can also give you the total volume of model material, support material, and the time it takes to print. All this can be pre-processed with the data, and then well before you take up the job for printing, you're very well sure about for making a job of this nature of a given size, what will be the expense with which it's going to call for, and the time it's going to take. And the time factor is again subjecting if it is one or two versus utilizing the entire build area. Now, when I talk about cutting down more on time, if you can pack the build to
Yes,
the
sir.
maximum utilization, then the time comes down. But if you are working on even one single part, and if that's going to take around 1 hour, and if you have 1 dozen parts that you have put up, and that may take around 3 hours. So ideally, the time factor is further shortened, which means the price of machine hour that you can work around again, saying that 1 hour my machine would cost you so much plus the material and the overheads all put together to make a part. You work around, this would be the quote with which you can talk to your customer, or you can arrive at the costing for achieving a part. So more the parts in a single print means your machine hour rate comes down, which ideally again cuts down the price of the total part cost. So that's exactly how 3D printing is used. And most of these service bureaus, etc., they nest multiple parts together and they work around what could be the delivery times and what could be the cost for a given part for a given customer, and that's exactly how it goes.
Yes, sir. Thank you very much, sir. It's a it's a good thing that I could able to understand some of the component from one component that I could able to understand. But the thing
Okay.
is like there could be the plastics like on the interior side and the exterior side, and some of the things is in the critical geometry areas and all. So it's a nice interaction with you, sir, Ganesh Babu garu.
Pleasure,
And
pleasure
thanks to
talking to
you.
you, Dr. Venugopal. Yeah, thank you.
Yeah, yeah, thanks to you, sir, and Pranachal. Thanks to you.
Thank you, sir. Thank you, sir.
Yeah,
Uh,
yeah.
okay, sir. Okay, Ganesh, sir. So I don't think we don't have any more questions. So thank you, Ganesh, sir. Thank you for your presentation. Thank you, everyone, for attending this webinar. As mentioned, I will share the PPT and recording on your registered email ID. Have a nice evening.
So, well, thank you, Pranjal, and thank you everyone for joining. Until the next time we meet, a big thank you to all of you. Look forward to seeing
Thank
you all
you.
in my next session. Thank you.
Thank you.